This is the ROS Developers Podcast, episode 101.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS Developers, and welcome to the ROS Developers Podcast, the podcast that gives you insights from the experts about how to program your robots with ROS. This is Ricardo from The Construct, and today I would like to dedicate this episode to all the ROS developers around the world that are working on developing autonomous cars, but of course, using ROS. Okay, so if you believe that the autonomous cars are something of the close future, if you are trying to build them, and if you are trying to build them by using ROS, then this episode is dedicated to you. Very good. Today, we are going to talk about how to use, a special simulator for designing autonomous cars. But before going into that, let me talk to you about the program that we have developed at The Construct for allowing you to become a robotics developer in a short amount of time, as short as 6 months, if possible, in the full program, or 12 months. So we have created a complete program that teaches you from the very beginning how to become a ROS developer, a robotics developer, by using ROS and other tools, creating programs for robots. So we start by teaching you from the basics of programming and math, and then we go straight into all the ROS topics necessary to program robots, including ROS 1 and ROS 2. Then we continue teaching you about the theory of robotics, just a little bit of theory that you may need in order to develop for robots. And then we finally go into the learning of development tools, all the DevOps software that you need to master in order to develop for robots and become a ROS developer. Yes, and then the final stage of the program is 1 month internship in a robotics company, maybe online or on site, maybe, but that's it. Then, of course, we provide a certificate that you can have and show to your future employers. And that's it. So here you have more details on the show notes. Have a look at it, and let me know also if you have any questions about this master program. Okay, then for today, let's welcome the speaker of today that we have here. So let me introduce Antonio Manuel Lopez. And Antonio is an ICREA Academia professor in the Computer Science Department of the Universitat Autonoma de Barcelona. And he's also the principal investigator in autonomous driving at the Computer Vision Center here in Spain. And he's one of the responsible of the open source Carla project at this Computer Vision Center. Welcome to the podcast, Antonio.
Thank you very much. Thank you for your invitation.
My pleasure, of course. And so when I introduced you, then I was telling you that you are responsible of Carla at the Computer Vision Center. What do you mean? Can you be responsible at other places?
Yes, the Carla simulator is an open project running, I think, right now, like for 5 years or even more. Mm-hmm. And from the very beginning, the responsibles of this project were the Intel labs in Santa Clara, California, mm-hmm. and the Computer Vision Center here in Barcelona. We have been working together for these years. So there is a general responsible worldwide of the project, which is Herman Ross, Dr. Herman Ross, in Intel, from Intel. And I'm taking care of the project here locally in the Computer Vision Center.
Okay, I see the difference. Okay, I understand now. So yeah, our salutations also to Herman Ross, that he may be listening to this podcast, and thank you also for developing this excellent project. But okay, but can you tell to the audience what is this Carla project?
Yes, in fact, we have been working in autonomous driving and driver assistance for many years. And one of the big issues that we had in the past is that here in the academia, it was very difficult to actually have a physical car with multi-sensor suite and all these things that you need to do research in autonomous driving and driver assistance in the real world. So we were lacking somehow to put our ideas and proposals in practice and going beyond results in images or accuracies in plots. We needed to see what was the effect of our ideas when driving a car it would be ideally in the real world, but this is too expensive and out of course for us and for many people. So we were looking for the alternative, which is to have a simulator, but it turns out that it was not there. It was not a simulator to, at least an open source simulator to do what we wanted to do in our research. So actually with, let's say, with the help of Intel and other sponsors along these years, what we have been building is open source simulator. At the moment, mainly focused to do training and testing of agents, AI agents for autonomous driving in the simulator. So many people can test their own ideas using this simulator from the academia, from private companies, because as I said, it's totally open source. Even the, let's say the content, the 3D content is given to the people because it's done from by us from the scratch, and the license of all this is MIT license, so it's kind of
awesome.
The restriction, let's say that the restriction is in the licenses coming from Unreal Engine, but not from Carla.
Yeah, but
So,
even sorry to interrupt you on this, but I think that also if I want to run your Carla simulator, even for running, so it's open. The running, so you don't have to buy anything from Unreal, any license, if you only want to run it.
Exactly. I think I'm not, let's say that I'm not expert in licenses, but I think that only if you want to sell some product, then you have to pay to Unreal, to Epic.
Okay.
But I would say anyone that want to do this should check it out.
Okay.
But for the purpose of the academia, let's say, you don't need to do it because you are only doing research, publishing papers, explaining your ideas and prove it in Carla. All this is okay. The good point is that here, I would like to stress this, is that from the very beginning, what has been built in Carla is relying not only on the ideas of people from the academia like me, but also from sponsors along these years that come from the industry, like Toyota Research Institute was one of our sponsors. At some point also General Motors, etc. So we have been hearing what are the needs of the industry also when doing this, and we were doing our best for both worlds, let's say.
It's excellent because if I have correctly understood, by having those sponsors, you are getting their feedback on what they actually would need also. So you can implement and dedicate time to develop some stuff that is useful in the real industry of this, right?
Yes. Some things are possible, others are not possible.
Okay.
but those that are possible, we prioritize them and we do it. Great.
So for all the ROS developers out there listening, you can also be a sponsor and request your features for
Yes.
Carla. For Carla, great. So here is the call for you. And then, why did you decide to use the Unreal Engine and not another one like Unity, which is very famous right now in robotics, or even a simulator? Like, why not to do that in Gazebo or Webot simulator?
Well, let's say that we have to reply to answer this question. We have to go back these 5 or 6 years.
Ah, yeah, okay.
Because maybe the decision today maybe could be the same, maybe
Yeah,
not.
maybe not.
It
Yeah,
depends. But at that point where we were deciding, let's say that simulators like Gazebo and others like this from robotics were not good for us because we are computer vision guys, and at least we need good images, nice images to do things. And then in these simulators, as far as I know, this was not really possible. So our actual possibilities were Unreal Engine and
Unity.
Actually, our first work was with Unity. We did also a very popular data set called Cynthia for training, let's say, for working in domain adaptation tasks for computer vision. This was done in Unity. But for that project, we went to Unreal because at that time it was easier to have good looking images. And also because the license policy at that point. I think that license policy have changed in Unity. Now is much better, but at that time it was not the case. We were talking also many times with the Unity people, and I think they have improved a lot their licenses. But for us it was more convenient for several reasons. Unity, and we work in Carla in Unity, and that's
in Unreal. Sorry,
in Unreal.
In Unreal, exactly. Yes. Yeah. Well, about what you mentioned of the new license for Unity, I interviewed Sarah Gibson from Unity team that is developing for robotics, or is trying to push Unity for robotics, and then she told us about the relaxation of the license, that also for execution of already made environments, then it's free. Also, you don't need to buy any license for the execution.
This was always the case for
Unreal
execution only. But if you want to do, if you wanted to do the development of the simulator at that time, that years ago, the developer, depending on the, let's say,
revenue
kind of institution. It was depending on the revenue, but also this is related to the institution in which you are working. And then maybe you needed to pay licenses. So,
okay.
But I think this is not the case anymore if you are doing things like we do. But let's say that it was also at that point easier to do nice images with Unreal.
Yes, and also had better support for Linux, and and C++, and so.
But I would say that for us this is not a sort of fight.
Okay.
And Unity, I also use Unity for other things, and there are other simulators done in Unity also. And I think that as much as open source simulators are in the market, or for the academia people, is better, because it's like if you are working with a static data set, like a data set of images for doing computer vision tasks, you don't want one single
instance
data set. You want to have several of them, and this is the same. If you want to do research, maybe you want to use several simulators. I don't know, but of course, I think that Carla should be for sure one of those. And actually, if you look at the number of citations that the original paper of Carla has in Google Scholar is quite a lot, which means that there is a lot of people doing research based on Carla.
Wow. Excellent. Congratulations. Congratulations for this successful project then. And let me ask you another question is, so you have already answered this, and then what about the current status? So is it a project that is still under development, or is it already closed?
No. I mean, this is so complex and in a way never-ending thing. So as far as we have fundings, sponsors, we keep working, and at the moment there are like, because we are recruiting these days, I think we are like 15 or 20 people already. I don't remember exactly the number, sorry. But I think that this is a very multidisciplinary team, because you have people which are programmers for Unreal Engine, for programmers that work more in control and local planning, programmers that are more deep learning with deep learning experiences. Of course, 3D digital artists. So this is really a multidisciplinary team, and it's a big team, and nowadays it's still all of them are still working in the project.
Okay, but then you see, if we are talking about a simulator, so what is the importance of deep learning in that project? So why do you need people working on that?
Well, there are two things. One I cannot tell you because it's still confidential.
You will have to kill me afterwards.
Yes, there is people waiting for that now in your door. But no, I was saying that, of course, if you for what is the simulator? We want to develop autonomous drivers, right? And they rely on what? They rely on artificial intelligence, but basically this artificial intelligence is some sort of deep learning model or several deep learning models processing the sensor data to output control commands to the car. So you need someone that is testing what is done in the simulator as a user.
Okay.
So we have, sometimes these are just PhD students or postdoc, whatever, but people in the CVC and other people maybe in Intel that is using what we are developing to be sure that the things are really as we want to be.
Okay, I got it. And then maybe you can even use those results as something for your own research and so on. And
yes, of course. I do my own research on Carla, of course. Yes. The only thing is that I don't participate in the leaderboard because this is would be strange that the responsibles of the leaderboard are participating. But other than this, yes, I do my research using Carla. Yes.
Okay, and this Carla simulator, does it work with ROS 1 or ROS 2?
Yes, we have a bridge for ROS 2. I think it's actually very easy to see in the documentation, this part. I think that, Carla has two modes of working. One is called synchronous, the other is asynchronous. The asynchronous is like the real world, that server and client are just running in parallel without waiting for the other. And the synchronous is when they wait for the other, because sometimes maybe the AI is so slow that if we want to see what it's doing in case it would be faster, you need the server to wait for. And I think that the ROS bridge now works in synchronous mode. Okay,
yeah, I can tell you that we are using it. This one, for ROS 2. Good. Yes. I will tell you in another moment about results and all
Okay,
that.
great.
Yeah. But
Great,
it's
great.
it's working, and we have used it for generating some maps and trying to
Yeah, in
localize the
fact,
robot.
if I come back to the team thing, part of the team is working to make these ROS and other kind of let's say interfaces with other third-party tools to work. So there is people doing this let's say link between different softwares or APIs or whatever to make it to work.
Yeah, and now that you mentioned, you provide an API. Yeah. So what is this API for? What can they do with this API?
Well, I don't remember all the things, of course, because for that is the documentation. But
Yeah, I understand.
let's say that in summary, you can do almost everything through the API. For instance, spawning cars, spawning pedestrians, setting the trajectories that you want the car to follow.
And
You gather the sensor data, like from a camera. You gather privileged information from the simulator, like the semantic segmentation of the images, the bounding boxes of the objects. In fact, I think now we are providing the bounding boxes of everything in the scene. And there is now, in the last version, there is even the possibility that you can change the texture of the things. Like you have the rod with one type of texture, and then you can change it to another, so that you can improve the variability of the data that you collect in Carla to train your AI models.
in real time while it is running. I have seen the videos. Yeah, very spectacular. Very cool.
Yeah, you do the training of the AI models offline, but still you can do these changes in the simulator
In real time.
to.
Yeah, maybe you later want to use this so once you have trained your model, then you want to apply, and then you can trick the model to see if it reacts properly, right?
Yeah. I'm sure that people out there is going to have more ideas than me right now what to do with this, because I mean, sometimes I have seen surprising applications with Carla that I was like, oh wow, I didn't thought of that.
About that. Yes. Yes, the people that they have a lot of time to think about it. Yes, it happens to us also. And okay, so then it's a breach on ROS2. And which kind of sensors are available?
Let's say that we have an API so that people can define their own sensors. So now there is cameras.
Off the shelf.
There are cameras, because this is actually natural for, let's say, simulators on top of frameworks for video games, because the images are let's say the main sensor for video games, right? So we have also a sort of I could say pseudo radar, because it's not really a radar, and as I would say also a simulated LiDAR. Of course, there are things that we can simulate on these other sensors, and others that right now we cannot. Mainly, sometimes is due to the engine below, and sometimes it's because you have to spend more time in the content of the world. For instance, if you want to simulate, I don't know if you know LiDAR, but probably yes. I'm sure that people in robotics all know what is a LiDAR. So
yes,
you know that there is two kinds of information. One is the 3D point, where is the point, and the other is some sort of luminance.
Yes,
if I can call it like this.
Intensity.
Intensity, yeah. The 3D point, the coordinates for us is possible to gather this kind of information. But if you want to have an intensity, this means that you have to put some, let's say, information in the content of the scene, so that the LiDAR can know how to interact with this information to become the proper intensity. So this is a matter of just putting more time in the content, and of course, probably changing some part of the software for doing that, but it's not a big issue. I think it's just a matter of time. But there are other things like if you want to simulate a rotating LiDAR like this, well, it's usually have these rotational LiDARs. This is more tricky because the engine usually is not. It's more for capturing images and it's not well aligned with this kind of other sensors. The way, let's say, we have to collect the information for these other sensors. Let's say that is not well aligned with respect to how the engine below all this is working. But okay, I think that from the very beginning we have faced different challenges, and at the end, with time enough, we are able to do what we want. It's just a matter of time.
Great. Yes. Okay. So at least the ones that typical ones that we already use for autonomous cars, the camera, the LiDAR, and even the radar, more or less, then we have it working and we can use them. Okay. Great. And what else? So yes, and so I've seen that in some of the videos that you provide kind of detectors, and also you mentioned about the bounding boxes. Are those detectors that you are providing already in Carla, or are using? So they are not actually detectors; they are just that like a got information that is asking the simulator for the information and providing this for automatically tagging or generating data sets. Is that?
Exactly, is that.
It's the second one.
Yes, is the ground truth or
the ground truth,
information. Yeah. Is this. With this information, the people can do their own detectors, semantic segmentation models, end-to-end driving models, whatever they want to do.
Okay. So this is already provided and running. So you can.
It's not only the sensor data. It's also the vehicle data, the speed, the acceleration, braking, even the let's say the direction where it's moving,
the steering,
these kind of things.
Okay. And then what about if we want to add our own cars, our own cities and all that? Is that possible, or do we have to stay with the ones that you are providing?
No, you can do your own, but in this case you have to do it in, let's say,
in Unreal.
You have to do it in Unreal.
And pay a license if... No, okay.
So.
And then about the maps, you mentioned that in some of your information on the website is that you can import maps from which one?
Open Drive, right?
Yes.
Yes, you refer. Yeah, this basically is the Open Drive is defining the let's say the environment, the static environment, and then we can read the Open Drive to generate the map. Actually, it's like how we store this information also.
And then, so you can create your own city, but then you have to populate with all the buildings and elements and like people moving around and objects and so on. Yeah, right?
Yeah, let's say that this is something that we do offline. We build our own cities because to make it interesting, you need to do it offline with time.
Yes,
once it's done, then you can open it in Carla, and then what is done in real time and changes to time is the spawning of dynamic objects, and also the weather conditions, the illumination, these kind of things can be changed in real time.
In real time.
Sensors, the sensors that you put in the car, all this can be done in real time. But the static environment, we usually do it offline, and that's it. You can probably every people can use their own pipeline to create the city, as far as at the end is in a format that we can read from Carla.
And then you can also spawn humans, pedestrians that are moving around, and also even you can define like their behavior in some sense, or is that about trajectories or other actions that they can do?
Let's say that we have some basic algorithm to move them in a way that they look not natural. They don't crash each other and other things. But we are, I'm sure that anyone that is working specifically in that topic can do many other algorithms to move the pedestrians, because you can do it yourself with the API.
Okay, great. Then I think that we have covered the customization of the environment, which is interesting. Maybe for just by curiosity, do you have the city of Barcelona?
No, not this would take a lot of time to be built, and it would be nice. Yes,
it would be nice, right? Yeah. Maybe the Barcelona major can sponsor this. I don't think so.
we will be happy, but I think that nowadays this is difficult.
It's very difficult.
In any case, let me say that for any to be in to know that the last in Carla, the best is going to the webpage, the carla.org, because sometimes I don't even know all the details, because
it's big. It's a big project. So I understand.
Carla, guys, if I said something wrong, sorry about, but I think I did it as it is.
Okay, no problem. I am sure that everyone will understand. And then, what about limitations of Carla? What can you tell us? For example, I am an autonomous cars researcher, and then I want to evaluate. Is Carla for me? So we have said many things that are good. Then, what is a drawback of Carla?
I would say that more than a drawback of Carla, I would rephrase this, and I would say the limitations. Simulators in general, not only Carla.
Okay.
And in general, of course, you can do a lot of things in simulation, but then you want to move your models to the real life, right?
Yeah.
And then still is not possible just, let's say, to cut and paste the model from the simulation world to the real world. You need to work in what is called domain adaptation, transfer learning, and all these things to make it work in this other real world environment. So I guess with the higher fidelity of any simulator, this gap could be lower. But even this is not clear. It's not totally clear. So I think that this is one topic for going from simulation to real world. And in the case of simulators like those built on top of, let's say, video game framework like Unity and Unreal, usually what you need to improve more is the physics, in the sense of fine grain physics.
Yeah.
Of course, things move, things crash, but if you want to, I don't know, to simulate the deformation of a car crashing, you have to do more work. It's not something automatically happening there.
Yeah.
You need to make it. We don't do it because for training the AI, we don't care how the car deforms when it crashes. We want to avoid the crash, that's all. But if someone would like to simulate a crash, how the car is deformed and things like that could not be done in Carla.
Yeah, yes. It's the same for grasping things because you need the friction in small locations, and it's very difficult. It's not very well simulated in Unreal and similar
Yeah,
engines.
I don't say that cannot be done. What I'm saying is that it's not there by default already available, and that's it. You use it, and that's it. You need to do something on top.
Okay. Then I think that well, you can tell me about some other projects that where Carla is being used that you are aware of.
To be honest, the best way of doing this, as I said before, is if you go to the Google Scholar and see the paper of Carla, you will see there a lot of publications referring to Carla. This is the way I look at what people is doing with Carla. Probably most of the papers are from the academia, but you can see companies, private companies also using Carla for doing their own experiments, big companies. So you can look at it. I would not like to start naming companies.
Okay.
But I know that there are many. And also in the academia, there are many universities using Carla. So yeah, more than I know.
Okay. And
I think just to give you additional information, if I'm not wrong, the second semester of 2020, I think it were more than 2 million of downloads.
Wow.
Something like that. It was a lot. I'm bad with the numbers, but I think it was like.
And that order.
Wow.
Yes. Awesome. Impressive.
I have not checked it in the last year. So, but I mean, there is a lot of people downloading Carla. Of course, doesn't mean that they later use it. But what is for sure is by looking to the papers in the Google Scholar, you will see the people that use it.
Okay, yes. Well, that's giving a measure of the interest for the project, at least, to say at least.
Yeah.
And then we are about to finish this interview, but I would like to ask you also, are you still looking for a senior Unreal Engine engineer, developer?
Yes.
Okay.
Yeah, we are looking for two, not for one. For two.
Oh, for two. Okay, so for us developers there that you have some experience with Unreal Engine, then that's your opportunity to work in an amazing project and then develop by using ROS, Unreal Engine and all that, and simulators and so on. So here is the call for the audience. And then I would like to finish the interview by asking you about, so you are a researcher on autonomous driving. So what do you think about autonomous cars? Do you think that it's going to be in the close future, still a long time? What is your opinion on that matter?
Well, this is a very broad question. I think that if you, I remember this question years ago, and some people were saying that 2020, but I think we are in 2022, and this is not yet there.
Yeah.
Let's say that the point is that this kind of question is too broad. You need to usually to be more specific. For instance, if we are talking about cars that move autonomously or operate autonomously in a specific scenario for performing a specific task, like let's say a bus moving in a given trajectory, which is always the same, then this you can find these kind of things already there in some places of the world. So this is done. But if you think in an autonomous car, like now that you take your car from your garage and you go to the
Yes, that's the one.
40 kilometers to work, and all this doesn't matter if you go through the town, through the highway, or through the whatever else more complicated
That's the
area.
one. That's the one.
Which is, I think, actually what people think about when they ask for this question.
Exactly.
This is for me, to my understanding, but of course think that I'm not working in a company, so people working in companies know this better than me for sure. But I think that this is not going to be soon here. I think that we need at least 15 or 20 years more until we don't even think about autonomous cars, because they are so common that it's like now the smartphone.
Yes.
Nobody
Okay.
think about smartphones as being something different than a phone, as when they started to be in the hands of some people. I think that it requires a lot of time, because it's not only about the technology, it's also about regulations. I mean, there are many dimensions for this problem that have to be addressed, and probably in some places of the world they will be faster, and in other places it will be not that fast, depending on many factors. But let's say that for me, I don't see it before 20 years.
In the close future.
In a way that we not even think that these cars are moving autonomously. So because they became regular things in our lives. But to reach this timing, still we need to keep working hard. So it's not something that just wait for this
and then it will happen.
No. You have to still work hard from the academia and from the industry, of course.
Yes. Okay. I agree completely with you. Okay, so that's all the time that we had for the interview today. So thank you very much, Antonio, for this awesome information about Carla that I wanted to know, and I'm sure that it's going to be a very interesting episode.
Let me finish by just giving thanks to all the Carla team, because it's a great team. They do a lot of work, hard work, very hard work, not only hard work, very hard work at all time. And I want to take this opportunity to give thanks to them, also to Germán Ross, the leading, the leader of the project worldwide, and of course to the Computer Vision Center, because their contribution here, helping every day many things that are needed to keep such a big team alive and working, is also something that is very, very valuable. And we have to remember that this is a public institution. So thank you very, very much to everybody.
Yes, thank you very much also from my point to all of you, because it's really useful, the project that you are doing. It's really useful. Thank you very much.
Thank you very much.
And thank you, Antonio. See you around the world.
See you.
Let's see if we can meet someday at the CBC, because we are so close, but with this thing about the COVID, we are here.
Yeah,
kind of stuck.
That's a nightmare. I for sure we are not introduced COVID in the Carla simulator.
Okay, great.
Yeah.
So you can put it COVID free, exactly, certified.
Yeah.
Great. Thank you very much, Antonio.
You're welcome.
And for all the audience there, I hope that you enjoyed this podcast episode. Remember to give us 5 stars on iTunes, Stitcher, Spotify, whatever you are listening to this. And that's all for today. See you the next week with a new lesson from the experts. And until then, keep pushing your ROS learning.